Welcome to the next part of steam and accessories. Now, before we go into the other aspect of accessories, if you recall that we have discussed the various other aspects of a boiler house, including the boiler, some of the part of the steam distribution network, steam traps, etc. In this particular chapter, we are going to discuss with the concept of economizer in detail, concept of superheater in detail. Apart from this, we will discuss the various safety devices attached to the boiler house. As you know that boiler is a pressure vessel, so it requires so many safety devices for smooth functioning and to prevent any kind of pressure based hazards. So, first we will discuss the economizer. Although briefly we had discussed this concept in different segments including the boiler and steam distribution network. Now see, the concept of economizer is to maximize the energy efficiency and to extract the excess amount of heat being liberated or attached to the flue gases. And you know that the flue gases they pass through the main boiler and superheated, they are having a significant quantity of heat. Now, if we discharge all these heat to the atmosphere, then definitely there would be a significant loss with respect to the energy. So, the energy in these flue gases, they can be used to improvise the thermal efficiency of the boiler. It may be utilized to preheat the different segments. Now, to achieve this, the flue gases are usually passed through the economizer. Now, economizer is nothing special, only thing it is a heat exchanger through which the feed water is pumped. Now, here you see that this is the boiler house. Now, you see that this is the feed water tank, and this feed water line comes from this way to the pump and the boiler. Now, here you see that this is the chimney through which we are passing through the flue gases, and this is the economizer through which we are preheating the feed water so that the thermal shock to the boiler can be avoided. Now, let us take the superheater. Now, we have already discussed a couple of segments of this superheater in past lectures. So, obviously, if you require the superheated steam, then you must have a saturated steam with us, and this must pass through the a superheater. Now, here you see that this superheater is situated. It is not any special device. Only thing is it's simple heat exchanger, where you may add the additional heat to the saturated steam to get the superheated steam. So, this saturated steam is passed through the source of heat to get this superheated steam. Now, let us have a look about the heat losses. Now, there are various heat losses attributed to the flue gas. And you can say the flue gases, they are the biggest single source of heat loss, and the engineering manager or chemical engineers or any other engineers, they can reduce much of these heat losses by simply adopting the various design phenomena. Now, these losses are attributed to the temperature of the gases leaving the furnace. Clearly, the hotter the gas in the stick, the less efficient the boiler, but you have to maintain certain temperature of this hotter gas to maintain the draft of those flue gases. Now, there may be a couple of things that these gases may be too hot for one or two reasons. Why? And the question in the engineering question is that why these gases are too hot. So, that means the burner is producing more heat than is required for a specific load of a boiler. That means you are pumping more and more fuel, and you are performing more combustion action in the burner. So, this means that the burners and the damper mechanism, it require the maintenance and recalibration that is purely based on the engineering calculation. Another thing is that the heat transfer surfaces within the boiler, they are not functioning correctly, and the heat is not being transferred to the water. So, this means that the heat transfer surfaces are contaminated and require cleaning. Again, some care is needed Now, too much of cooling to the flue gas may result in the temperature falling below the dew points. We have already gone through this dew point concept, and the potential for corrosion is also increased. So, you have to be maintained, and it's a responsibility of the engineers to maintain the flue gas temperature at appropriate level, so that either corrosion or excessive heat loss can be avoided. Apart from this, since we are maintaining a very high temperature to the boiler, then there may be a significant chances of radiation heat losses, and this is I mean, you can say it's a very rare to avoid these losses. Now, next aspect is burner and control. You know that in the boiler we are using different type of burners, sometimes single burner, sometimes multiple burners, to produce the combustible mixture as well as to produce the desired temperature. Now, if in a very synchronized manner, if we say that what is burner? So, burner are devices, those who are responsible for proper mixing of fuel and air in the correct proportion for efficient and complete combustion. So, it is one of the deliverables that any burner must have, that is, they must go for a proper mixing of combustible mixture and perform the combustion reaction. And moreover, determining the shape and the direction of the flame. So, sometimes you need to direct so that the only targeted element should be heated. So, let us take a couple of example of the burners. One of the example is the pressure jet burner. Now, here you see this is the burner body. Here we are having a high pressure fuel oil, maybe from some external source the pressure is imparted, and through this orifice the oil is being sprayed to the boiler furnace, where this atomizing nozzle is supplying the desired quantity of air or excess air to make this particular mixture a combustible mixture for the firing within the boiler. There are various advantages attached to the pressure jet burners. They are having a very low cost, relatively low cost with compared to the other burners, and they are very simple to maintain, as evident in this particular figure. But simultaneously they are having certain disadvantages. One is that if plant operating characteristics vary considerably over the course of a day, then boiler will have to be taken off line to change the nozzle, because here you are having a orifice supported by a nozzle. So, you have to change to meet out the load changeover, and since it is a very orifice driven function, so it can be easily blocked by the debris or carbon, and this means that well maintenance and fine meshing strainers are quite essential for the proper functioning of this boiler. Another type of burner is that is the rotary cup burner. Now, here you see that this is the rotating disc, and you are supplying the fuel, and here there are three different sources of air based on the requirement. Here you are having the primary air. Here you are supplying the air from the forced draught fan. The primary air is again bifurcated over here to provide the secondary and a tertiary air, and this is the rotary cup which rotates maybe in between 4000 to 5800 rpm, and by this way the maximizing the heat efficiency of the burner, so that the energy and the combustible mixture is imparted to the main furnace zone. Again, the advantage of these rotary cup burners, they are robust in design, they are good turn down ratio, and the fuel viscosity is less critical. Sometimes due to the atmospheric conditions, sometimes to the supply of the end, sometimes because of the quality of the fuel, the viscosity of the fuel is again sometimes very higher or sometimes very low. So, that is not the question with respect to the rotary cup burner. There are certain disadvantages of a rotary cup burner. They are more expensive to buy and maintain. They are basically, you can say, the gas burners. Now, being a gas, atomization is not an issue, and the proper mixing of a gas with the appropriate amount of air is that is required for the combustion. So sometimes you may need to replace all these the oil fired burner to these gas fired burner, so that you can minimize certain disadvantages of these rotary cup burners. Another is the dual fuel burner. Sometimes maybe because of the various variety of reasons, you may go for oil as well as gas type of a fuel source. So this dual fuel burners, they offer a very good candidacy towards this particular approach. Now here you see that you are having oil and you are having gas. So those two sources of fuel are altogether different, with the supply of calculated amount of air inlet. Now here you see that this is the most critical zone, where the gas ports, oil jets and the primary air ports, all these things are mixed together to form a combustible mixture to supply in the furnace zone of the boiler. Now let us talk about certain boiler fittings and mountings. They are also the integral part of the boiler. The reason is that without those fittings and mountings, you cannot assure the smooth functioning of the boiler. So you may have a number of items, those must be fitted to the steam boilers with an objective of improvisation in the operation, to maximization of the efficiency, and above all the safety aspect. So one of the key factor in the boiler fitting and mounting is the boiler nameplate. See, this is not only the nameplate, but it also provides you variable information that up to what pressure you can handle this boiler, who is the manufacturer and who is the certifying authority, so that if you are moving that particular boiler from one country to another country, then you need to take some more additional certification under the edges of the targeted countries regulations, etc. So all these kind of informations, they are enlisted in the boiler nameplate. So apart from this, the serial number, then the model number, because usually the companies or manufacturers, they do vary their models in due course of time, and some of the old models may get phased out. Now these two informations are quite essential when you are looking for some spare parts of those boilers, and spare parts are already very sensitive, because without the essential parts you cannot run boiler efficiently. Apart from this, you are having the output, that what is the maximum designed output, design pressure, maximum working pressure and hydraulic test pressure. All these things are essential for the safety aspect, because if you go beyond this hydraulic test pressure, or if you have achieved these maximum working pressure, that gives a ceiling beyond which you cannot go, otherwise there may be certain safety issues pertaining to it. Then regular testing of this boiler for assessment of this pressure vessel code is essential. So you need to put that on which date they performed the test of that particular boiler. Then again, one more important thing is that what is the design standards, in which under which design code these boilers are designed, and above all these things should be addressed with the help of boiler manufacturer's name, etc. So this is you can say the nameplate is a very key part of the boiler. Sometimes people ask that what are the various essential aspects for a good boiler. So essential of a good boiler is like the boiler should be capable of generating steam at the required pressure and of the required quality quickly with the minimum fuel consumption. This is the foremost requirement. The initial cost and installation cost and other maintenance cost of the boiler should not be too high, otherwise your economics will be at the stake. The boiler should be light in weight, should need at least least amount of brickwork construction, and should occupy a very small floor area. That is again a very important thing for the boiler. It should maintain the fluctuating demand of steam supply without being overheated, and that is because precisely the steam steady demand of steam nobody can predict, and therefore it must cater the need of this fluctuating demand. The different part of the boiler should be easily approachable for the repairs, because sometimes scale formation, sometimes the other safety issue, they demand that replacement of the part, maintenance of the part, etc. All these things are essential, so it should be easily approachable. Since boilers, again, boiler is the heart of any industry. The boiler should have only minimum joints, and those two should be away from direct flames. Otherwise, expansion may create a severe problem with respect to safety. The boiler should offer the ease of dismantling the part, erection at site within reasonable time and labor. This is necessary for boiler which has to be transported quite often. Now, for efficient heat transmission rate, the water and the flue gases should have maximum velocity without incurring heavy frictional losses, just to minimize the impact of scale formation within the tubes, etc. There should be no deposition of mud and other debris or foreign particles on the heated surface. Otherwise, the heat transfer aspect may be badly affected. The boiler should confirm the safety regulations as laid down by the Boiler Act, and as I told you that these boiler acts are different for different countries, different states. So, this must be conferred by the applicable Boiler Act. Now, another important accessories mounting in a boiler is the safety valve, because see, I told you that this is a pressure vessel, and it is just like your domestic pressure cooker, where there are two type of safety devices. One is the safety valve, another one is the steam vent. These two are the safety devices. Otherwise, your domestic pressure cooker, it is boiler is excessively pressurized vessel. So, in case of any eventuality or any built up excessive pressure, boiler should be capable to release that particular excessive pressure with the help of safety devices. So, when we talk about the safety devices, safety valves come into the picture. A safety valve is a device that automatically relieves the excessive pressure and actuated by the pressure upstream of the valve. It is usually characterized by either full opening pop action and is primarily used for gas or vapor service. Now, this type of valve with fully open at a set pressure and remain fully open until the boiler pressure or workable pressure reaches to the preset temperature. The preset temperature is set lower than the lifting pressure. So, obviously, this is essential for the smooth functioning of the boiler. Now, different type of safety valves are fitted to a steam boiler plant, but they must meet the different criteria. The one criteria is that the total discharge capacity of the safety valve must be at least equal to the capacity of the boiler, so that you can have a safe operation. Similarly, the full rated discharge capacity of the safety valve must be achieved within 110% of the boiler design pressure. Now, this the maximum set pressure of the safety valve, this shall be designed for the maximum permissible working pressure of the boiler. If you recall the rating plate of the boiler, there it was clear cut mentioned that what should be the maximum working pressure. So, this gives an idea. Now, there must be an adequate margin between the normal operating pressure of the boiler and set pressure of the safety valve. Now, this is the internal anatomy of the safety valve. This is the spring loaded safety valve. Here this is the spring and this is the seat and disc. We will discuss all these things in due course of time later on. Now, once we are using this safety valve, we must comply the certain safety valve regulations, and that too depend on the boiler to boiler acts, Indian boiler regulation. So, all these things are the governing factors or regulators towards the safety valve regulation as well as the boiler operation. So, The regulation says that a boiler shall be fitted with at least one safety valve sized for the rated output of the boiler. We have already given the mathematical correlation or statement which decides that what should be the capacity of the safety valve. The discharge pipe work from the safety valve must be unobstructed and drained at the base to prevent the accumulation of the condensate, because as soon as the steam releases through the safety valve, it should be condensed, and it's the condensate, which is usually at the temperature of the steam, must be recovered as quickly as possible. It will be quite normal that the internal diameter of the discharge pipe work to be more than the internal diameter of the safety valve outlet connection, but under no circumstances it should be less. Apart from this, another accessory is the boiler stop valves. So, a steam boiler must be fitted with a stop valve, also sometimes known as the crown valve, which isolates the steam boiler and its pressure from the process or plant. So, this is the basic figure of the boiler stop valve. Here you are having this ring hand wheel, rising hand wheel, and sometimes it is called the ring, or sometimes it is known as the crown wheel, and material for the construction of this is the cast iron. Now, as soon as and you see that this particular juncture or joint, this is fitted with the shell of the boiler, and if you open or close, the steam can go like this. So now it is in the closed position. So this valve is completely seated with the passage. So you can maintain the steam passage through this valve. Now, these valves usually being manufactured from cast iron, with the steel and a bronze being used for the higher pressure application. Another thing is important in the boiler accessories mounting, that is the feed water check valve. Now, this is the basic cut section of feed water check valve. The feed water check valve is installed in the boiler feed water line between the feed pump and boiler. The boiler feed stop valve usually is fitted at the boiler shell. The check valve includes a spring equivalent to the head of water in the elevated feed tank when there is no pressure in the boiler. So, this prevents the boiler being flooded by the static head from the boiler feed tank. Now, here you see that where we are fitting, this is the main boiler shell, and this is the feed water stop valve. So, the feed water check valve is situated here, and this is the normal feed water flow. Now, see, boiler obviously for the production of steam, boiler uses the water, and we discussed that the quality of water is extremely important, because the natural water may contain certain dirt, debris, etc., total dissolved solids, etc. Apart from this, some hardness, and sometimes if we are reheating the boiler, maybe condensate recovery, maybe through some other aspect, it must be the quality of the boiler water should be checked. So, because it is again essential for the smooth functioning as well as the proper efficiency of the boiler. So, the maintenance of water quality is extremely essential for the safe and efficient operation of any steam boiler. The measurement and control of the various parameter is a very complex topic, and which also covered by the number of regulations, because you cannot discharge the condensate as such, because it carries the heat value as well as significant quantity. And you see that for proper efficient operation, you need to demineralized or deionized water as well. One of the major issue in the boiler operation is the total dissolved solids, or the TDS. So, a boiler must control or must be operate within the permissible TDS, otherwise the scales will be on the higher side and the heat transfer rate, etc., will be having a negative impact. Now, this is the TDS sensor, and this is the isolating valve and a blowdown valve, and this is the sample cooler, and this is your main boiler arena. So, it is this TDS sensor usually sense the quantum of TDS, and if it is beyond permissible limit, then isolating valve will be actuated to cut short the supply of water, or some remedial measures or some chemical dosing may take place. So, this is again for the utmost important. Now, you see that the different type of scales may formed over the period of time, and the concentration may go up, and you are having a reheating of boiler water over the period of time. So, some sludge may form over the period. Now, this bottom blow down, this ejects the sludge or sediments from the bottom of the boiler. Now, this the control is large only key operated valve, and this valve might normally be opened for a period of say about 5 to 6 seconds once per shift. Now, here you see that this is a removable key which usually fit over here, and they usually operates in as per the directional requirement, and by this way significant quantity of sludge or sediments may come out from the boiler. But due care must be taken, because these sludge and sediments, they may have the temperature at equal to the boiler operating temperature. Here is more pictorial thing. Here you are having the blow down valve, which we have already shown here. Now, this blow down valve is connected to the blow down vessel. Here, because usually this blow down comes out in the form of high temperature as well as excessive pressure. So, you need to perform the flashing operation to this blow down vessel, and sludge, whatever concentrated sludge can be discarded over here, and vapors may go out from this way, and the condensate may come out from this way. One of the key factor in the boiler is the pressure gauge, and obviously without measuring the pressure you cannot proceed further. So, pressure gauge is again integral part, and some of the boilers, those who are working at a very high temperature and pressure, they may have some 1 or 2 pressure gauge. Now, usually this indicates what is the normal working pressure and what is the maximum working pressure by either color codes or some siren system. There are certain gauge glasses and fittings to see or to visualize that what is going on inside the boiler, and all the steam boilers are fitted with at least one water level indicator. So, the gauge glasses and a water level indicator is one of those things. Now, a gauge glass shows the current level of water in the boiler. We have already discussed that what is the impact of the water level in the boiler with respect to if it is too high or if it is too low. So, they should be fitted with a protector around them, but this should not hinder any visibility of the water level. Here you see that the glass, and this is the protector shield you see, and the steam cock. So, you can clearly see that what is the level of water inside the boiler. And by this way you can control the water level, because we have discussed that if the level is too high or if level is too low, in that case the operation of the boiler would be extremely difficult. There are certain internally mounted level controls, and usually they are equipped with the various type of sensors. So, the level control systems with sensors, for sometimes they are referred as a probe, duly supported by the protection tubes, if you see in this particular figure. Now, these internally mounted level controls, they provide a high degree of safety than those fitted externally. Sometimes they may equipped with a level alarm system. This may also provide a self-checking function on system integrity, and these protection tubes are fitted to discourage the movement of water ground around the sensor. There are certain air vents and vacuum breakers are also equipped in the boiler, and the reason is quite obvious. When a boiler is started from cold, the steam space is full of air, and usually you know that this air does not carry any heat value. So, it adversely affect the steam plant performance due to its effect of blanketing heat exchange surfaces. So, you need to remove this air, and this air can also give rise to the corrosion in the condensate system if not removed adequately, and this air can be simply purged from the steam space using a simple cock. So, in this particular lecture, we have discussed the different accessories and mountings attributed to the boiler, and we discussed about the economizer, superheaters, we discussed about briefly about the other mountings, air vents, and essential part like pressure gauge, etc. So, if you wish to have a further reading, we have enlisted couple of references for your convenience. Thank you very much.